can hear you. Hello. All right. We are live. I hope people can hear me. Stuff I can't. The tough part with streams is they don't tell you if people can hear you or if people can't hear you. Whatever. Hmm, Don't mind this. This is work in progress. I need to put the lights here. Um. So I need to put these lights on. So yeah, it's it's work. But yeah. All right. Let's get started with AZ-500 study. Um, is it lagging? Hmm. It looks like it's lagging. Let's take a look. Why is Steam? Steam is the worst. Sometimes it's like, hey, let's take up all your memory for no reason, just a Steam client, not you know. Anyway, all right, AZ-500. Funny story before we start. So last week I think we spoke, we studied managed identities on Azure, for compute and all that stuff. And funnily enough, um, all these topics actually came up this week, where managed identity was a big topic, whether to use managed identity on the compute, which in the case of what we wanted to do was not possible, or to use a service principal name to just use the API and whatnot. Um, but yeah, so that that's why I think the most valuable part of a certification is not the piece of paper you get at the end, but um, the experience you get from it. It's very useful, and you actually get actionable knowledge out of this. Um, I do have to do some network security stuff, and let me share my screen. So I do have to do some network security stuff this week. I have to set up. Um, Thank you. I have to set up some networks this week at work, so I'm really looking forward to getting better at all this stuff. Um, Probably not gonna use firewalls or front door or all that stuff at work. Um, Mostly because work has a central firewall that is managed, that is not, um, that is a network that works with something that works with our physical devices. Um, but always interesting to learn. So let's go. Let's start the stream. All right. So think of security in layers. The network layer is important. You need to lock down the network with tools like security groups, Bastion. If you don't know what Bastion is, it's something that allows you to remote into virtual machines without really giving them a public IP or whatever. I don't know if it's without giving them a public IP, but it definitely helps you remote into uh, virtual machines just in time. Front door, which is the how you is something you put to get access to your APIs that are inside. Um, when a bad actor has to invest time and effort to break into your network or gain access to resources, if they break in, the more likely they are to leave you alone. Wait, did I misread this? This when a bad actor has to invest time and effort to break into your network or gain access to resources, if they break in, the more likely access to resources. If they break in, the more likely they are to leave you alone. I think this sentence could have some could use some reworking, huh, Microsoft? Or I'm just not good at English. Where is it? Um, Grammarly. Let's see what Grammarly says. All right. Oh, Grammarly's gone. Down here. New document. Oops. Okay, let's get this document going. Let's see if I was wrong. Okay, done. Okay. All right. I was right. You need a comma there. I know it's not important to this whole discussion. And now I actually lost the stream. Okay, we're back. I think sometimes the thing I find with these is that there's a lot of things that English wise could be rewritten. There's a lot of sentences I trip on. I don't know if I'm the only one who does that. There's a lot of sentences that I read and I'm like, what is this sentence meaning? Okay. So what this sentence means is that the harder you make it for an attacker to come and attack you, the more likely they are to not bother. Because of course, an attacker is not going to bother with somebody who's a lot of work. Like there's so many easy targets out there that they have unpatched machines, they have public IPs with like unpatched servers and all that stuff. Like they're not gonna bother with you if you have a good security. So that's the point they're trying to make is even if you don't do it perfectly, if you make it harder for somebody to break into your system, then they will give up. So that's really what security is about. Is not about making something necessarily foolproof, but it's about making something hard enough that it is not worth investing the time. Okay, a security engineer uses network security features to restrict, monitor, and manage network traffic once it reaches your Azure network. You will work on such tasks as set up network security groups and application security groups, deploy service endpoints and private links, and configure front door and express route. Okay. All right, for 500. So that's the 15 to 20%. Okay. All right. Learning objectives. Deploy and configure network security groups to protect Azure solutions. Configure and knock down service endpoints and private links. Secure your applications with application gateway, web app firewall, and front door, and configure express route to protect your network traffic. Network security groups. Yeah, so network security groups are the most basic firewall that exists. It's basically it's not smart. It basically takes source destination port protocol and then just allows and blocks as needed, as you described. So yeah, we can talk about this, but yeah, that's really the basic thing. Network traffic can be filtered from Azure resources in a virtual network group. A network security group contains security rules that allow or deny inbound traffic to or outbound traffic from network traffic from several types of Azure resources. For each rule, you can specify source and destination, port, and protocol. Yeah, so it's a major pain. But if like for example, if you have a service that only uses port 443 from this server to this server, it's perfect because you don't need to do much more than that. Deny everything, allow 443 in between the two, and you're good. All right. It makes it very easy, and it's free. Important piece to learn. Network security groups are free. And I hope I'm still correct about this. If they're not free, they're very cheap. Our network security group rules So you have the name for the rule, and I think this is, again, naming convention. I think a name is just no spaces, right? No spaces, no underscores, no special name. I don't know why Microsoft does that. Microsoft, if you hear me, please give us the ability to create friendly names, even though you don't want it to be friendly. Okay. Direction, so inbound, outbound towards the traffic. Priority, um, it's when you apply the rules, right? Um, Access, whether it's allowed or denied. Source address, so either CIDR address, whatever. Source port, you can have a range of ports, or if you have started for any. And same thing for destination and then your protocol. Okay, custom network security group rules. There's predefined rules that exist for inbound and outbound traffic. You can't delete these rules, but you can overwrite them. In the meantime, let me get a Azure Portal window going so we can take a look. Oh, I'm doing it again. Doing it again. Custom. We here. All right. Let's create a VNet. Yeah. Okay. Why you? Yeah. There you go. Sorry, I'm just trying to get stuff going in the background for you guys so we can have. I really need to prepare these better. Yeah, so we're going to look at this. Let's do this. Okay. I lost my Azure. All right, let's look at Azure. Zoom in a little bit. All right, let's create a VNet because we need a VNet before. Do we need? I don't think we need a VNet. Okay. The autocomplete here is not the greatest. Yeah, they've done this, but I don't know why there's a plan if there's no options. Tube, VNet. I don't want to just read. It's good to just go in and like see what is in there because it's very easy to read, but it's better when if you see it and you get your hands on things and understand things. All right, so here's the rules that they were saying are predefined, right? Allow VNet inbound. Those are like basic rules that um, if you don't have them, you could basically lose access to your network and resources and all that stuff. So they put it with a high level priority. Priorities go from, I think they go from 100 to like 65,550, because basically they're like allow anything and whatever. But that number priority here, the lower the number, the sooner it will be evaluated. Um, so when you do NSGs, just think about it as it's going to sort these rules by number, and it's going to go from the first one to the last one. So higher priority is a lower number. So it's the opposite of what you would think. It's priority number one, right? All right. So that's an NSG, and see you can see, and let's create a new rule. How do I? Okay, inbound rule. Let's add, and then see you have the source. You can do IP address, service tag. application security group. And if we go back here, they were actually defining this. Where is this? Oh, so see, this is not this is not really up to date, right? Because source, see, source, destination, action priority, but they're not saying, they're not talking about these. So that's new. Anyway, whew. I don't even know where I was going with this. I went back here to show you something, and then I think we were talking about tags. What is service tag? Yeah, you can have tags that just, you know, just to define a group of sources. So for example, internet, right? If you use internet as a service tag, I'm assuming here, instead of defining IP addresses and ranges and all that stuff for what is internet, Microsoft already has those tags predefined for you. So it's basically everything but private networks, right? Then you have all these like virtual net, let's say Azure Load Balancer. This would be like, all right, this is everything that is from, here's the list of IP addresses for Azure Load Balancers and all that stuff. So this is like just predefined sources in terms of IPs that you don't have to manage and know. This is a list managed by Microsoft. So that's what this means when you use service tag. IP addresses is really up to you to define what the ranges are, what you want. And application security group is whatever traffic comes from or to, well, from, because it's a source. An application security group. So these are meant to make it slightly easier for you to manage things. And then any is like any source, right? It's whatever traffic comes in, apply this rule regardless of where they come from, right? So you can say, for example, I want to, from any source, I want to destination service tag internet and port range. We're going to say port range and we're going to deny, right? So if we put this rule, basically from any source that's input, like the traffic originates from any port, destination internet for whatever service you want. Otherwise, you can have like specific like ports that are predefined for you. But here we're saying any port, destination, internet, and TCP protocol, we're going to deny it. And we're going to call it like deny, sorry, internet. See, okay. I just wanted to show you the naming convention. Letter, number, ends with a letter, number, or underscore. May contain only letters, numbers, underscore, period, and hyphens. Okay. So here, when we do this, we add this. What this means, and we have a little warning. What does this little warning mean? When we do this, basically what's going to happen is this is priority 100. This is the highest priority you could have. And what are you telling me here? What's your... This rule denies virtual network access. If you wish to allow virtual network access to your virtual network, add an inbound rule with higher priority to allow virtual network to virtual network. Okay. Oh yeah, because we're doing any source coming into the network with a destination of outside the network. It's crazy. But I mean, I hope you get the idea of how this works now. Um, source would be any, right? Destination internet. It's blocked. Okay. Whatever. All right. You can design NSGs to isolate virtual networks in security zones like the model used by on-premise infrastructure does. You can apply NSGs to subnets, which allows you to create protected protected screened subnets or demilitarized zones. I don't know why they keep saying DMZ. Um, that can restrict traffic flow to all the machines residing within that subnet. With the classic deployment model, you can also assign NSGs to individual computers to control traffic that is both destined for and leaving the VM. Yeah. So yeah, you can apply this at a network interface level. Um, it makes it more complicated, right? If you apply to individual virtual machines as opposed to a whole network. But if you're very peculiar about how you want machines to communicate with the network, that's what you would use. But keep in mind that if you put your NSG on your virtual machine and that's your role, then every virtual machine will have to have its NSG managed, as opposed to putting multiple similar um, virtual machines on the same subnet with the same NSG. You can create them in a resource group, but you can share them with other resource groups in the subscription. Yes. Um, so what you can do, what this means is, for example, you can say, I will have a resource groups with all my NSGs, and you then put all your NSGs in that resource group just to easily organize things. So yeah. Sorry, I'm just looking ahead. Okay. When implementing NSGs, these are the limits to keep in mind. By default, you can create 100 NSGs per region per subscription. Okay. You can raise this to 400. That sounds like very overkill to me. If you have this many NSGs, yeah, that is a lot of network rules to manage in a single subscription. Um, that is one big subscription. Anyway, you can only apply one NSG to a VM, subnet, or network adapter, um, which means you can apply. So what this means here, you can apply to the VM, the subnet, or the network adapter. So if you have a VM with more than one network adapter, you can have multiple NSGs, right? By default, you can have up to 200 rules in a single NSG. You can raise that to 500 by contacting Azure support. Again, this sounds very overkill. I think at this point, you probably would want much smarter rules. But, you know, some companies are very picky about how they do things. An individual subnet can have 0, 1, or one associated NSG. Okay. What this means is one NSG per subnet. Per subnet. Right? So if you look here, you have a subnet here. You have a VNet, you have a subnet. You can apply the NSG at the subnet, but you can also apply it at the network interface. And an individual network interface can also have 0 or 1 associated NSG. So you can effectively have dual traffic restriction for a virtual machine by associated NSG first to a subnet, then another NSG to the virtual machine's network interface. The application of NSG rules in this case depends upon the direction of traffic and priority of applied security rules. Okay. So basically, if what I understand, if the traffic comes from the network interface, this VM NSG is the one evaluating the traffic first, then it goes to the subnet NSG, right? And the other way around. If traffic comes from the subnet NSG evaluates first, and then the VM NSG. Okay. In this example, for inbound traffic, the subnet NSG, so inbound coming from the subnet, is evaluated first. Any traffic allowed through the subnet NSG is then evaluated by the VM. The reverse is applicable for outbound traffic, with VM NSG being evaluated first, and any traffic allowed through the VM NSG is then evaluated by the subnet NSG. All right, so that's what we were saying. This allows for granular security rule application. For example, you might want to allow inbound internet access to a few application VMs, such as front-end VMs, under a subnet, but restrict inbound internet access to other VMs, such as database and other backend VMs. Okay, so I see where this is going. So imagine you have Can I create a new window? I'm just trying to get the... Sorry, other work in the background. All right, new file. Sure. All right, let's save this somewhere. Sure. You're gonna work on the first try. It looks like we're going... Yay. Okay. All right, cool. So let's look at this. So let's draw some diagrams. So we have a network. All right. Sure. Virtual network right here. All right. Let's say this is a subnet, right? We have a network, we have a subnet, we have we have a virtual machine here and here and here, and sure, we'll have an SQL database. Okay. All right, arrange, center. Okay. I never know which way to do this. All right. Align metals, arrange, distribute, horizontal. Okay, that looks cleaner. All right, network interface. Let's design this network and look at how this looks. All right. All right. Range, align, middle. All right, cool. Then we take this, connect it here, take this, connect it here, take this, connect it here, this, connect it here. All right, network. All right, and now we NSGs. All right. And you know what? We're just going to put one right here at the network level. Cool. All right, so this one's connected to the network. This one is connected to this VM. This one is connected to this VM. All right. So what this NSG would do is allow, I'm just going to say, let's see, this one is going to allow internet inbound. So that's what they're saying, right? You have an NSG that allows internet inbound to your whole VNet. But then, actually, this NSG, these would actually go here. All right. Sorry about that. But then this is front end. All right. Front end. Backend. Database. Okay. But now what we want is this traffic is now allowed inbound, but you don't want your backend machine to receive traffic from the internet, right? So one way you could do it is have your NSG here say, okay, I'm going to allow traffic to these addresses, but not these. That's one solution. But it's a little bit harder. So what you would do is you say, okay, there's like these two machines that are backend, and these two don't really want to have most of the internet traffic going to them. So here what we do is we put the NSGs on these cards so that when traffic, I wish there was is there a draw? Is there a pencil? No. So when traffic comes from the internet, right, to here, we can say, hey, you can't reach the backend server. The only machine that can reach the backend, right, are these two machines. Oh, wait, where did you go? Okay. I was actually trying to get a little arrow. Okay. All right. I have no idea what is happening here. We're just gonna pretend it didn't happen. But anyway, you can have this machine is the only one that can talk to this machine. So traffic goes here from the internet, goes to this machine, and then this machine talks to this machine. And then if needed, this machine can actually talk back out, right? Without allowing any inbound connection. So yeah, so that's what an NSG does. But here you're just doing it per, like, you're specifying the ports, destination, source, and all that stuff. Okay, let's go do something. Let's go here. Oh. Well, you see that they were drawing the same thing I was drawing. All right, so several resources from Azure services. Yeah. Okay. Several resources from Azure services can be deployed into an Azure virtual network. You can associate 0, 1, or 1 network security group to each virtual network, subnet, or network interface in a virtual machine. The same network security group can be associated to as many subnets and network interfaces as you choose, which is great because if you have like, let's say you have two, let's go back here. Let's take this and let's assume this is a subnet, right? Copy this, paste it here. Okay. Let's make sure this, I hope this all thing, okay. Paste it here and I want the same rules, right? I duplicate the VNet. And so what I can do is just say, well, now this network is the one associated with this. But I can also do this, right? If it's the same inbound rule to just block internet traffic, I can also do this. All right, and this. Oops. What is happening today? Today is just one of these days where things don't work the way you want them to. All right, and I can also do this. Okay. Send to back. All right, I can do this. And I can actually just take this out, right, and put it like this. So that makes it a lot easier. You can just associate the rules. It's basically rules being evaluated, right? It's not an actual interface, right? So it's just rules that get applied to this. So yeah, so you can do this. Isn't it great? And these two can actually be, I mean, this drawing is getting ridiculous, but hopefully you'll follow what I'm trying to do here. Send to back. Okay, I don't know what is happening here, but you get the idea. Here you can have these in their own security group outside of wherever these VNets resides. These VNets can all be in different security groups. They can be in their own security groups, right? Okay, this is just not working the way I wanted to this morning. Send to back, right? This is getting hard to follow, but you can have them in different security groups, and like this, you can organize this. So you can just so the thing that is practical with this is if you have multiple rules that apply to different resources, you don't have to recreate the network security groups, right? This is allow inbound, this is deny inbound. You're good. All right. Okay. The same network security group can be associated to as many subnets and network interfaces you choose. That's what we said. The following picture illustrates different scenarios for how network security groups might be deployed to allow network traffic to and from the internet over TCP port 80. Okay. Yeah, so here you have a subnet. You have an NSG on the subnet level. You allow and then you have your traffic evaluated once you have this VM1. Here, traffic, the rule is only evaluated for the network. I mean, this is applied to the network. So this rule gets applied evaluated by this NSG. This is a little bit deceptive, I think. And then Yeah, it gets evaluated by the NSG, even though it doesn't go through there in their diagram, because you have applied it to the subnet. All traffic in the subnet will be evaluated, even if the traffic itself does not get affected by any rules, right? So if we say I will only have rules for this source, right? Internet port 80 to this VM1, the traffic still gets evaluated because, as we saw in Azure here, we have this source any deny all inbound, right? We have these um, deny all outbound. These rules apply to everyone. So um, just because it's not directly explicitly controlling the traffic flow to or from this machine, it is still being evaluated. Okay. Here on this one though, subnet 2, there's no NSG on the subnet level. So the only one evaluating the rules is the one on the interface. And this one, there's absolutely, it's like free for all. This is go to the internet, do whatever you want. Connection in, sure. Connection out, sure. So this is really the free for all network security model, um, which is more or less basically what you would get if you just deploy a virtual machine that is not on a private network, right? You just bypass the whole thing. Okay. Oh, hey, look. Okay, that's exactly what I was saying. Um, okay, VM1 rules in SDG1 a process since it's associated with the VM, unless you've created a rule that allows port 80 inbound, the traffic is denied by deny all inbound network security group. This group, rule right here. All right, and never evaluated by NSG2 since NSG2 is associated with the network interface. If NSG1 has a security rule that allows port 80, the traffic is then processed by NSG2 here, and blah blah blah. Rule NSG1 a process because VM2 is also on the subnet. See, that's what I was saying. Like it should go like this to NSG1 and then back out. Um, yeah, and VM4 yeah, so I mean that's basically what I was saying. I can read that to you, but it's basically saying everything I was saying. It's important to note that the security rules in an NSG associated to a subnet can affect connectivity between VMs within it. Yes, let's go back to our drawing. Um, where did I put this drawing? Let's go back to the drawing. You could have a rule on this NSG, right, that says this traffic. Can I? Let's see if I can actually just do X, right? not the best. Um, okay, I can't. Whatever. You get the idea. I can just say this traffic is denied for in the rule. I can say deny. Why do I want to deny port 80? Right. So in this NSG here, I can have this right here. This NSG that is applied at the subnet level can impact the traffic within the subnet. All right. So you can control traffic within like this. I should do more of these diagrams. People who are online, do you like the diagrams? Should I do more diagrams in the future to explain things? I think I think it's better than just me speaking. But you guys are basically my boss. I have a big boss, which is the person I'm married to. That's the number one boss. And then I have my work boss for work, and I have you guys for YouTube. So you guys are my boss. So tell me what you want. Um, wow, 1 of 14. That is a long one, and I talk a lot. Maybe that also does. All right. In this topic, we look at application security groups, which are built on network security groups. A quick review of security groups reminds us that you can filter network traffic to and from Azure resources in an Azure virtual network with a network security group. A network security group contains security rules that allow or deny inbound traffic or inbound traffic, blah, blah, blah. For each rule, you can specify destination, protocol, blah, blah, blah. Application security groups enable you to configure network security as a natural extension of an application structure. You can group VMs and define network security policies based on those groups, right? So here, I'm just gonna have to redo this drawing. We'll do that. You can reuse security policies at scale without manual maintenance of explicit IP addresses. The platform manages the complexity of explicit IP addresses and multiple rule sets, allowing you to focus on business logic. Consider the following illustration, right? This is all done TCP through network security groups. In the illustration, NIC1 and NIC2 are member of ASG Web ASG. Yeah. So they're member of here. I didn't see that. ASG Web. This is an application security group. And the NIC3 is part of the logic security group, and NIC4 is part of the DB security group, application security group. Though each network interface in this example is a member of only one ASG, a network interface can be part of multiple ASGs up to the Azure limit. None of the network interface have an associated network security group. NSG1 is associated to both subnets and contains the following rules. NSG1 allow HTTP inbound, deny database all, and allow database business logic. The rules that I specify, give me a second. I need a drink. The rules that specify ASG, that specify an ASG as the resource, as a source or destination, are only applied to the network interfaces that are member of the ASG. If the network interface is not a member of an ASG, the rule is not applied to the network interface, even though a network security group is associated with a subnet. Okay. And there are limits to the number of ASGs in the subscription. You can specify one ASG to as the okay. You know what? Too many words, not enough. Azure, let's go and do the thing. All right. Let's go back to our subscription. Let's go to our YouTube one. And let's go to our resource groups. Let's go back to VNets. And let's create here a application security group. All right, let's create this. Let's look at what it takes to create this. I hate, why do you do that? Come on. Why do you do that? All right. All right, so here it's one of those that you just create. There's nothing to configure. It's just like, hey, I want this thing. Same as resource groups. Just very little information to actually get the resource created. And all the configuration is done at the resource level. All right. We have an ASG. We have tags, properties. Am I missing something? I don't really use application security groups, but am I missing something? Is this something you do just for fun because you want an application security group? All right, then let's read on. Maybe I'm missing something. Application security groups along with NSGs have brought multiple benefits. What? All right. If somebody knows how application security groups work, please let me know what needs to be done here. Is it? Do I need to zoom out and there's something I didn't see? Whoa. Okay. Okay, blah blah blah. The each network, blah blah blah. My application security group and configure network security as a natural extension of an application structure. Your limits, next step. What am I missing? Oh. Yeah. But I think I know what it is. It's this. Right. I think what we're doing here now is we go back to our network security group and we do inbound security rules and we add a rule in a source application security group, and then we do this security group. No, application security groups. But then you need to do a better job at this, Microsoft. Like, it sounds easy, but then when you go and do it, it's like, what is happening here? Come on. Is this something we just do for fun? Please, if someone knows, I do not understand what is happening here. Alerts. I am so confused. So, okay. Let's try something. Let's try to figure out how this thing works because yeah. It's great in network interface. Apparently that's something you apply to the network interface, right? All right. Let's create a network interface. Don't give me a drop down if there's no options. Okay, virtual network. Network security group. Resource group VNet. Okay, none. Currently, select subscription lack an existing. Create a virtual network first. Wow, that's rude. Um, why? Stop doing that. All right, let's create this. This is very confusing, Microsoft. That's the thing I don't like with Microsoft Learn is that there's a lot of words and very little hands-on. Um, and even though it's nice to have these descriptions, these explanations, um, being able to do hands-on is, to me, like extremely important. Um, now we need to create a network interface. I would create a VM, but we can just create a network interface without a VM. It's very practical. I hate this. I really, really hate this when you are in a resource group and say, I want to create a new resource. And it's like, oh, let me change your subscription and your um your resource group for you. It's like, use the context of where I clicked, Microsoft. Keep that in mind when you do your things so that I don't have to reselect the subscription. I've created professionally at work, I've created resources in the wrong place and then I have to hunt them down because Microsoft was like, you know what? I'm gonna change. I'm gonna change things on you. No, don't do it. You better than that. All right, that's my little pet peeve. All right, let's create this. Yeah, press this super quick. Go security group. Go put it in an SG. Save this. All right. I am so confused by this whole. I'm gonna have to look it up, honestly. Like, I'm going to have to look up what this is and how it works. Um, because it is just ridiculous that we have a resource that just exists, but you can't configure it. All right, I think it's time to move on. Microsoft, do better. Um, Sorry. It's like somebody was like, hey, let's create this thing. They're like, yeah, let's do it. But what do we put in there? I don't know. We're just going to do it. People will get confused. They won't use it. It's fine. Service endpoints. A virtual network endpoint provides the identity of your virtual network to the Azure service. Once service endpoints are enabled on your virtual network, you can secure Azure service resources to your virtual network by adding a virtual network rule to the resource. Today, Azure service traffic from a virtual network uses a public IP address as a source IP address. With service endpoint, service traffic switches to use the virtual network private addresses as the source IP address when accessing the Azure service from a virtual network. Okay. So if you have a storage account, right, traffic to that storage account by default will come from the internet. But if you do a private endpoint, right, you're now saying, hey, you're no longer on the internet anymore. You're no longer reachable through the internet service endpoint. But now you are discoverable only within my network. So that's basically what a private endpoint does. Um, improve security for your Azure service resources. VNet private address space can be overlapping and so cannot be used to uniquely identify traffic. Can be overlapping and so cannot be used to uniquely identify traffic originating from your VNet. Service endpoints provide the abilities to secure Azure service resources to your virtual network by extended VNet identity to the service. Once service endpoints are enabled in your virtual network, you can secure Azure service resources to your virtual network by adding a virtual network role to the resource. This provides improved security by removing public internet access to the resource, allowing traffic only from your virtual network. Yep. Optimal routing for Azure service traffic from your virtual network. Today, any route in your virtual network that forces internet traffic to your premise or virtual network appliance known as forced tunneling also force Azure service traffic to take the same route as the internet traffic. Endpoints always take service traffic directly from your virtual network to the service on the Microsoft Azure Backbone network. Okay, and simple to set up with less management overhead. It is rather simple to do. Sorry. Lots of talking. See, this one has like more than one module. Application security groups had like multiple little units. And they have another one close. All right, scenario, peer connected virtual network. All right. Provide benefits in those scenarios. Peer connected multiple virtual networks to secure Azure. Filtering, securing Azure resources service deployed directly into virtual networks. This traffic from our virtual machines. I mean, oh, okay. Traffic from a virtual network to Azure services. Okay, this one I can see. You're filtering and you can analyze the traffic, which is not something you can do with a with a Microsoft endpoint, right? If you do a Microsoft service without any directly available over the public internet, you can't really monitor the traffic to and from your resources easily, and you can't filter that either, like unless you do like IP whitelisting. But if you want to inspect or filter the traffic, you can just be like, hey, I want my storage account to only be available within like my network. Only traffic originating from my own network can access it. Yeah, you can do virtual network. You can do IP filtering, but this gives you a much better granularity. So you can say only IT can access this storage account, right? Because you say, okay, IT has the subnet, and then we can like filter IT out to access the storage account. Uh, Securing Azure resources to services deployed directly into a virtual network. You can directly deploy various Azure services into specific subnets in a virtual network. You can secure Azure service resources to manage service subnets by setting up a service endpoint or on the manager. This traffic from an Azure virtual machine. Virtual machine disk traffic for managed and unmanaged disk isn't affected by service endpoint. Routing changes for just too many. Oh yeah, see, you can do rules. So that's what it is. Like for let's go create a rule. Let's go here. Service tags. And these are your endpoints, right? So you can, because it's using private endpoints, right? Um, Here you can just filter on the service, right? All right. I'm kind of brain dead this morning. Sorry about that. That being said, I will have to say that the whole application security group thing did kind of kill my brain. Am I lagging on your end? I see the the stream and I see it lagging, so just curious if it's lagging on your end. All right, private link works on an approval call flow model wherein the private link service consumer can request a connection to the service provider for consuming the service. The service provider can then decide whether to allow the consumer to connect or not. Azure Private Link enables the service provider to manage the private endpoint connection on the resource. What does that mean? There are two connection approval methods that a private link service consumer can choose from. Automatic, if the service consumer has RBAC permissions. The resource consumer can choose the... Okay, but what is a private link? Back to Azure. Wait, did I not bring this here? Back to Azure. Okay. No lag. Good. All right. Private link service. What is this? How does this get configured? Why do you keep changing this? Why? I hate you so much. Right, rules. So you need a load balancer with IP addresses. Why do you do things like this? Here's a lesson that's super short about this thing that's super complicated. Um, Poorly explained. What? Whatever. I just have to say that even though I do Azure all day, every day, I still get frustrated by Microsoft. I love Microsoft. Microsoft is a great company, but sometimes it's like, what is happening here? What are you telling me? Yeah, that's the problem when you have experts explain things. It's like, oh, it's obvious. Okay. Gateway is a web traffic load balancer that enables you to manage traffic to your web applications. Traditional load balancers operate at the transport level, OSI layer for TCP and UDP, so that's protocol transport layer. OSI, let me see. I'm just trying to get the OSI layers out. You know what you need, Microsoft, when you do this Microsoft Learn thing? You need to have like links, like Wikipedia. Um, so that's like OSI layer. What is that? Don't assume everybody's an expert. All right, physical layer, data link, network, transport layer. Right. Um, Traditional. Okay, load balancer use OSI, so transport layer, TCP, UDP, manage the traffic like this, and route-based traffic based on source address and port destination. Blah blah blah. And Azure load balancers work that way. Application Gateway can make routing decisions based on additional attributes of an HTTP request. For example, your path, URI path, or host headers. For example, you can route traffic based on incoming URL. So if images is in the incoming URL, you can route traffic to a specific server known as a pool configured for images. If video is in the URL, traffic is routed to another pool that's optimized for video. That's great. That's great. So for example, you would have like, if we talk about Netflix, right? You would have um, basic traffic for loading the front page, right? Then you have traffic for loading images of the um, Netflix. Let's get Netflix up. Sorry. Shh. Okay, Netflix here, right? You have the whole website that's loaded by a server who's like, hey, here's I'm optimized to give you the HTML, right? Then you put a request back and you're like, here's a server that's optimized to give you images. And then when you do things like this, you're like, here's a server that's optimized for giving you snippets of a show, right? And then here's a server that's optimized to give you the actual video. Um, so yeah, that's pretty cool. Yeah, that's very neat. I'm sure how much um, how much does this cost? Huh? Let's see. This is probably one of the pricey services. That's not too bad. Let's do East US. I'll put it in Linux. Oh. Oh, that's app service. Sorry. I'm not. I'm not all there mentally today. So how does this work? Basic, small. Does it have to be on 24/7? Does it scale? I'm assuming one has to be on 24/7. Application gateway includes the following feature: SSL, termination, auto scaling. Okay, cool. Yeah, that's one thing I was saying. Can scale up and down based on changing traffic and load patterns. It removes the requirement to choose deployment size or instance count. Zone redundancy, yeah, to make sure that it's always on. Static VIP. Did I miss something? Stop using. I'm assuming VIP means virtual IP. What is a static VIP? Come on. I am not happy this morning, in case you didn't know. Web application firewall. Okay, you have firewall service. Ingress control for AKS. Ingress for AKS. So Kubernetes is a bunch of little containers, and you can have this like the specialized container for images, the specialized container for videos and whatever. So that's the first thing that came to my mind when I thought about this whole balancing by URL. Now URL based routing, multiple site hosting, redirection, session affinity, so keep the same server for the same cookies, connection draining to help disconnect people, custom error page, rewrite HTTP headers, and sizing. Okay. I am done. What's left? Application Firewall, Azure Front Door, Express Route. Try this exercise. Now let's check. I'm just gonna end this here. I might do another stream to finish this, unless people have objections. It's okay, right? When you study until your brain can't take it and stop. Because at this point, I am personally not learning anything new. My brain is hurting. My brain needs a break. And if you've been on this stream the whole time and you got this far, your brain probably needs a break too. So, I'm going to call it a stream, right? I'm going to call it. There will be another stream in half an hour or so about a different topic. I still haven't figured out what it was going to be. If anybody has suggestions, give them to me. I might do AZ-100, or I might just do Terraform. I might do Terraform today. But yeah, that's it for this for today. My brain is just saturated with difficulty understanding what Microsoft is saying. So it was fun-ish. But yeah, I'm gonna end it and rest my voice and rest my brain. See you in the next stream. All right, bye.